Okay, horizontally launched projectiles. And on your unit test, like these ones, you should be able to spot pretty quickly, and they're actually really quite nice. Um, it's the non-horizontally launched projectiles that's a little bit more challenging. Okay, so if an object travels through the air only under the influence of gravity, we call it a projectile. And they can be thrown horizontally or at angles. And in this lesson, we're only going to be worried about horizontally. That's all we're going to be worried about. So what will the path of a ball thrown horizontally off a cliff be? We're looking for this word here, parabolic. So it looks like this. Just like I have on the whiteboard. And there's more pictures to come that will do it better justice. But basically, you're looking for parabolic. So just like this projectile, ball goes up, ball goes down. What shape does it make? It's like a U shape, right? Is it a U shape? Pretty much. But if we throw it horizontally, like if I pushed something off a desk, that's basically what we're thinking about. If you push an object off a desk, you only give it a horizontal velocity. Okay, let's keep going. So I love this picture. It puts the horizontal and the vertical components of the trajectory at various positions on the actual path. So like the red dot there. Well, let's start with the black dot. What's happening with the black dot? The black dot is the initial push, correct? So it has only Vx, and that's what you could write up there, Vx only. So Vx only on the black dot. Notice that the vertical component at the black dot is not there. There is no vertical component at the black dot. And then once the projectile is airborne at the red dot, here's the red dot, it has the tiniest little component of velocity vertically, and that's because it's now in free fall, in a sense. The acceleration of gravity is now affecting this object. And look at the horizontal component. Did it change? No. So what path does the ball take? The path the ball takes is the resultant of the x and the y. It's at a certain angle, right? What happens at the purple dot? X stays the same, but y is increasing in the negative direction. The resultant of that is now angled further down. Now look at the blue dot. Now the y velocity has taken over. It's larger than the x velocity. So the resultant is angled more down. It's got a much larger angle. And if you think about the relationship for trigonometry, like what happens when the opposite is much smaller than the adjacent? You can see a small angle in here. But what happens when the opposite is much larger than the adjacent? Then you have a much larger angle on that resultant. And I think most of you would be familiar with this picture because in your everyday existence you've experienced projectiles in your life. Just throwing a baseball, right? Like imagine those, you guys ever see those videos where they try those super shots like in basketball? Like what's those guys do, those videos? You guys know what I'm talking about? They try those crazy trick shots. And like they throw the basketball from like the top of an arena and then it flies forever and then it lands into the hoop. Like I wouldn't want to be catching the ball at the end there. But like it's not too bad if I just throw it from here because gravity hasn't been able to act for too long. But if gravity works for quite a while, if that thing falls for quite a long time, look at how large that y component gets. Okay, and then it's going quite quickly. Okay, so this is basically a summarizing page of all the stuff that we've talked about. Okay? So gravity always acts down, and all this stuff we've talked about. So this is a nice little summary page for you. More of the same stuff. We can revisit this on the PowerPoint because the GIF won't work on this software. Let's go right into one of these questions. So a cannon is fired horizontally. Right there, if you study, you're going to be like, okay, boom, horizontal projectile question. Then I can go like this. Vyi is 0. What does that tell me? That the initial velocity vertically is 0. So that's something you can do as soon as you see that. From a 10-meter cliff, so usually I just draw like a right angle like this. And this is 10. And they're telling you muzzle velocity, like, don't worry too much about that language. That's just the horizontal components. So Vxi is 55 meters per second. And you don't even necessarily need the I because you understand that this one's constant and it won't change. The horizontal component of the velocity is constant and it won't change. So then it says, well, how long is the projectile in the air for? And then it says, what is the range horizontally? So we're looking for two things, time and dx. This is the two things we're looking for. Range is another word for horizontal displacement. So we talked yesterday about the riverboat problems and how the time is the same for both components. Obviously, because whatever's happening in x is going to happen in y simultaneously. So again, this is the same for both components. And we have to think dimensionally. If you want to talk about gravity and you want to talk about the 10 meters, gravity acts which way? Left and right or up and down? Up and down. That 10 meters, is that left and right or up and down? Up and down. So if I want to use the 10 meters, I can use gravity and I can use the Vyi. Okay, so the one formula that works gorgeous for this is this one here. This kinematics equation that we talked about last week is gorgeous because why? The initial velocity is, yeah, you just have the 1/2 at squared, and you know what a is. A is 9.81 down. So that's the go-to equation. But the important thing is that you understand that that equation, this is for the y component of the velocity. And why is that? Because the y component is the one accelerating, not the x component. The x component is uniform motion. You agree? So which formula do I use for the x component? Just Vt. So dx equals Vx times t is for the x component only because it's not accelerating. So one of the goals of the question is to find the range, the horizontal displacement. So what do I need for that? Vx, which I have, 55 meters per second, multiplied by the time. Do I have the time? I don't have the time, but it's the same for both components. So what I can do is I can go into the y component and solve for the time. Using the fact that the initial velocity is 0 for the y component, this whole term disappears because 0 times t is 0. The displacement vertically is 10 meters. And I'm going to use the 1/2 9.81 and then solve for t squared. So I've omitted the negative. Why is that okay? I should have a negative there. I should. But if I put a negative there, you'd put the negative on the 10 as well, right? Because which way does the ball displace from the reference point? If you're on the top of the cliff there, which way does the ball displace? Down. And it also accelerates down. So if that's down and that's down, they're in the same direction, right? So they just need the same sign. So I've just decided to keep them both positive. You can also have them both negative, but the exact same thing will happen. Is that okay for people? Like, the one thing that will screw you up is if you try to memorize the fact that like 9.81 should always be down, but then you forget to put the negative on the 10. Like, which way does it displace? Does it displace up? When would it displace up? Only if you threw it up, right? So you got to be careful. If that's positive 10, that's going to be positive 10. Just think that you can just assign down to be positive. Anyways, timesing both sides by 2, and then dividing by 9.81, and then square rooting. You guys okay with that? Should be at this point. Times both sides by 2. That gets rid of the half. And then divide out the 9.81. And then square root. What'd you guys get? Okay, 1.4 seconds. Now that 1.4 seconds, you can now slide over here. And you'll get the 55 times 1.4 as 79 meters. Okay, and 79 meters in the direction that you fired it. So in this case, it looks like I'm firing it east. It would follow like this. I'll draw a nice big blue line. That big blue line right there, that's the dx. That's dx. It's about 79 meters. Did you round? Yeah, you can't round in between, right? So like when I took the square root of the 2.038735984, I got 1.427843123, and then I times that by 55. Yeah, in the calculator you want to keep as much accuracy as possible. This looks like it's in the wrong section. Oh no, never mind. A ball is thrown horizontally. I thought I read it wrong. A ball is thrown horizontally from the top of a building at a velocity of 6.5 meters per second. So right away, identify what's this 6.5? Vx or Vy? Vx, good. Vx, 6.5. Oh, look at this. They gave us the time. That's nice. 7.5 seconds. Then it wants how high is the building. So what are they searching for? In which direction? Vertically, right? Always just think with these projectiles, you got to have a left-right dimension and an up-down dimension. So you have velocities in the up, down, and you got velocities in the left, right. You got displacements in the up, down, and displacements in the left, right. And that's some of the hardest things for physics students when they're first learning this kind of stuff. It's new to them. It's like, wow, I have to deal with two dimensions at one time, and they work simultaneously for the actual thing that happens, the resultant. So anyways, let's keep going. How far from the base of the building does the ball land? So what else are they searching for? How far from the base, right? How far from the base. So that's a horizontal displacement. And what's the only thing they gave us? Horizontal speed and time. What formula relates the horizontal speed? Horizontal is uniform or non-uniform? Uniform. So horizontal is VT. And you have both of those. So you can get the 6.5 times 7.5. 48.75 with two significant digits, 49 meters. Now what's the other formula that we have for the horizontal component? Or pardon me, the vertical component. dy is equal to VIT, but except it's the vertical component, plus the 1/2 AT squared. This one's nice because they give us the time. What happens to the VIY? Cancels out because it's 0. So this is just a straight calculation for dx and dy. Whoa. 9.81, and the time, 7.5 squared. This formula, don't forget to square it. So many people will be like, I did everything right, but I don't know what I did wrong. And then I'm like trying to troubleshoot their page, and then I just find out that they forgot to square. So don't forget that square. It's a common mistake. 276 meters. So you could go to two significant digits, 2.8 times 10 to the 2 meters. And which direction do you displace? Do you displace up? Good. So you can just put a negative in front of that, or you can put down. And for the dx, like it depends. There's no picture. It wasn't told you, so you can just make something up. Like maybe it goes to the right, maybe it goes to the left. Who knows? But it definitely goes down. Definitely goes down. Do you guys feel okay about this? So maybe for the study notes, like horizontal projectiles, there's some key points you have to remind yourself. Uniform motion equation for the horizontal components. So that's this one. Uniform motion for the horizontal components. Non-uniform motion for the vertical components. And the VIY is 0. And the time is the same for both. So that's something that you have to have like pretty much mastered. I'll let you guys try this one. Alright, so for this question, you were supposed to be able to accomplish this on your own. I would just use the fact that dy equals 1/2 AT squared. So twice dy over a square root will give you t. I think someone was showing me 4.16. I like that. Yeah, 4.2, but you got 3 sig digs, so 4.16 is good. Seconds. And then once you have the time and you want to solve for Vx, that would be d over t. So dx over t, so then the 67.8 over the 4.16. What'd you guys get for that one? 16.3? You're rounding in between? All right, let's do this one together. Maria, I can help you with that after. So this one's a little bit different. This one is a bit of a segue into Monday's lesson. So This one you're not throwing it horizontally. So this is a completely different scenario. A ball is thrown vertically up. So what is that? If you throw something vertically up, does it have any horizontal component to it? Vertically up, vertically down. It shouldn't go left or right at all. Just up and down in the same line if it was a perfect situation. So they give you a upwards velocity of 15. So VI is 15. It's positive. It's 15 meters per second up. Okay. Because there's no horizontal component, I'm just ignoring the subscripts. I don't need to put a VIY because it's the only component. Okay. And this component, vertically component, is affected by gravity because acceleration always points down. So what will its velocity be at its highest point? I think most of you already know this answer. So VF at the highest point. So it's like VF at the maximum height. What would it be? 0. Excellent. Because eventually the ball will start to come down, right? Ball's in the air, it's going up. So if it's traveling up, its velocity is positive. Eventually that ball will start to come down. So then the velocity's negative. So somewhere it had to have been 0. If it's positive and then all of a sudden it's negative, somewhere it had to have been 0. And it's 0 right at the top. So for a moment in time it has 0 velocity, and that's right at the top. So this, I don't know if this VF max is a good word, but the VF at the top. The VF at the top is 0. So then what is the ball's maximum height? So ball goes up, ball comes down on the same line. It's just drawn off to the side so that you can visualize it. So what would be this displacement? Well, you can use the fact that you have a VI of 15 and a VF of 0 and an A value of 9.81 down, and you can solve for the maximum height. So VF squared and VI squared and 2AD, because this formula doesn't depend on time. And really, I've been given nothing in terms of the time. So I have a 0 squared. I got a positive 15 squared. I got a 2, a negative 9.81, and a D. You'll notice I included the negative on this one because it wasn't like I just dropped it. I gave it an initial velocity up. So it travels up, but it accelerates down. If you put a positive 9.81 there, you're telling the equation that you throw it up and then it accelerates up. Do you see the difference? It would be like if you're in one of those wind tunnels and it's like the wind is going up and then you threw it up and then the ball just kept going up. That would be if that was positive. But because it's negative, ball goes up, but then ball comes down. Now this is where a physics student needs to be strong in their math, but essentially you don't have to worry about it because you can just equate it or just solve, like simplify it. I mean, that's what I would do. Just simplify this. 9.81 times 2, I should have that memorized. 19.62. So if you don't, if you move that 15 squared to the other side, it would need a negative, but because it's being squared, you might think it should be positive, so just be careful about exponents. But if you just simplify things first, it becomes much easier. I moved the 19.62D over to the other side because it's negative on the right. It will be positive on the left. And now I can divide out the 19.62 and end up at a positive result, which hopefully makes sense because when you throw the ball up to a maximum height, it's displacing positively. I got about 11.5. A displacement of positive 11.46. So 2 significant digits, I'm just going to put 11 meters positive. So we got the first bullet, we got the second bullet. Let's try the third bullet. And the third bullet, how fast will the ball be moving after 1 second? This one will really test if you understand what's going on. Like, what do you start at? What's the initial velocity? 15, right? And then how much velocity is lost every second? 9.81, right? What's 15 take away 9.81? Does that make sense, what I just talked about? What's the unit on acceleration? Meter per second. Per second. So every second, how much meters per second do you lose? 9.81, because it's gravity. And you have a VI that's positive and an A that's down. So they work against each other. So the initial velocity is trying to go up, but the acceleration is trying to pull it down. So they work against each other. So it's not an addition, it's a subtraction. It's just 15 take away 9.81. If you want to use a formula, instead of just thinking about it, you'd want to go with this one. A equals VF minus VI over T. Multiply both sides by T. And then you want to add VI to both sides. And then you can see how this works. Negative 9.81 times how many seconds? Just 1. And then you just have to add that initial velocity of 15. You'll get VF. What would your speed be after 2 seconds? How about this question? Are you still traveling up after 2 seconds? Negative 9.81 times 2 is 19. Plus the 15. Yeah, after 2 seconds, you're actually headed down, right? Okay. What was the answer to this one again? 5.19, thank you. And it's positive, right? So it's still going up after 1 second. After 1 second, it's still going up. But if you check, after 2 seconds, it's going down. Now, this last question, I just want to talk about how it's understood to be answered in this class. What will the ball's velocity be when it strikes the ground? You have to make the assumption that it lands where it was thrown. So it's exactly symmetrical. So when it strikes the ground, what they mean is the ball's position the same as when it was thrown. So they're asking you, what's the velocity when it comes back to where it started? Ball goes up, ball comes down. So I'm thinking, like, if I had a ball in my hand, I'm more interested not when it hits the ground, because I don't know the displacement between my hand and the ground, but where it goes up and where it comes down back to my hand. What will the speed be when it comes back to where it left? No. Like the moment, yeah, good. What'd you say? Yeah, the same. Did you guys see that? It's exactly symmetric. So it's the same. What will the ball's velocity be when it strikes the ground? Negative 15 meters per second. Because it's the same magnitude, but the opposite direction. So here's the homework, page 142, 1 to 8. I'll write it on the board for you, page 42, 142, 1 to 8.